My TTL computer. Today is going to be our wrap-up video in this series, and we're going to just talk a little bit about some of the projects that influenced my work, and then we'll just conclude with some final thoughts about this approach. Okay, so we started out with really as Ben Eater project as the main influencer on my project, and some of the significant differences here between my approach and Ben's approach is that everything is bus connected in my TTL computer, right? We have one set of switches. Ben had two sets of data switches in his solution that were used a multiplexer to select the lines. Everything is bus connected here in this approach. Also, the A and the B registers are bus connected to the ALU with my TTL computer. Those were direct wired with Ben's project. Also, Ben used EPROMs for his control unit and for his display unit. You know, the major difference between my project and Ben's is that I used PIC microcontrollers to implement the control unit, the UARTs, and the ALU and the display unit are PIC microcontrollers. And again, I use those really as drop-in replacements for, you know, either 7400 series logic or for the EPROMs. I almost really could remove those and replace them back with the same elements that Ben used in his project. But now that I have the microcontrollers here, I've used them for, you know, extra capabilities like the boot process off of the ALU and some of the extended things I did, the boot process off the UART rather, and some extended things I did with the ALU. And the other thing that's different about my project is the ALU maintains the flag registers, you know, for the conditional jumps. Traditional solutions take those flags registers and they feed them in as an input to the controller. I did not do that for two reasons. One, I kind of didn't have I did not have the IO lines to use there, but also my ALU is right adjacent to my program counter. And what I did is the control unit actually sends a signal to the ALU that says raise a jump signal if the carry is not set, or raise a jump signal to the program counter if the zero flag is not set. So that was, I haven't seen anybody able to do anything like that. And actually it worked out really well for my project. Okay, so the Ben Eater project, that was one of the, you know, obviously the primary influencer here on my project. The other influencer was SLU4's approach with his minimal UART computer. And that was really the impetus to really take the Ben Eater project, you know, much farther. So I kind of put this project as like halfway between maybe the Ben Eater project and the minimal UART is, you know, my TTL computer is kind of in the middle there. But something that I took away from SLU4's work was that I used his software stack approach, where, you know, the bus floats to FF, and then that is used as the stack pointer address, and then the stack pointer is implemented really in the microcode. There is no dedicated stack pointer, so I took that approach from SLU4, and then really the main, also the UART, obviously, right? Looking at in his UART solution, even though I did that differently than he did, but I really took inspiration from his UART and his terminal capabilities that he built, and also his assembler and his emulator work that he did in his project. that really was a significant influence for me to take this project, as far as I did with all of those elements, with the assembler and the emulator and the terminal and everything. But that was really the inspiration, was to see all those cool things that Slew 4 had done there in his projects. Okay, so then that kind of brings us to my final thoughts and about this approach. And I think one of the main, so I kind of had two objectives going into this project. One was to really minimize the hardware that was going to be needed to realize the solution, and that drove kind of the decision for having everything bus connected. It just minimized the hardware, and the other main driver was to build with what I had. So I kind of really used the digital elements that I had on hand, and that was one of the drivers for going with the PIC microcontrollers instead of a lot of the EEPROMs and things. I didn't have those elements, but I did have PIC microcontrollers, which I've heavily used in the past, and had a good library of software for those. But so that kind of brings me to the final question is, would I recommend this approach to somebody else as a viable approach? And I kind of, unfortunately, would kind of say likely not. Maybe, but likely not, because I'm a programmer by trade, and I have a lot of time in programming on PIC microcontrollers and multi-threaded programming for computers, which is a flavor of real-time programming. And I spent a lot of time. You saw how much time on working and reworking on all of the microcontrollers, the controller and the ALU. I spent tons and tons of time getting the firmware to be correct for those things. So really, it was a huge effort, time and programming effort. I mean, I have hundreds of lines of code that I put together for all of the firmware that was needed here. So would I recommend this approach for someone else? Likely not. This approach might be more viable at the really slow clock speeds. If you remember, we started out with only like 15 hertz, and every time I increased the clock speed, the firmware broke again, right? I had to revisit the controller firmware. I had to revisit the ALU firmware every single time, and so it took a lot of effort to get that code where it needed to be be able to accommodate 500 hertz on the clock, which is what we were able to achieve. So that all said, this has been a really great project. This is the most complicated project I've ever built. It really brought together so many of my skills and disciplines I've built up over the years, my electronic skill set, my programming skills and the firmware, the development. And I really learned so much on this project. It was a really fabulous project. I achieved way beyond what I originally thought would be possible. So I only thought it was fitting that to end the series kind of where we began, and running our old friend, the up-down program. And we see that this is running again with counting from 0 to 99, and then back down to 0 again. So I have one final surprise reveal for you. So our speed limit on my TTL computer has been 500 hertz for quite some time. So I'm going to reveal now that I have been able to achieve a speed doubling again. And this is my TTL computer running reliably at 1000 hertz. And thank you, Updown Program, for all the glitches you pointed out in the past. And thanks, everybody, for hanging in with me on this project. I hope it was enjoyable and that you learn something, and that this influences you to do your own My TTL computer in whatever approach that you think best for you. I think it's one of the reasons why I did this project and published it online was for people to A, to inspire people, but B, for people to be able to glean, right? Take bits and pieces from all different projects that you see and that you like, or you thought that they were good ways. Bring them all together in your own approach, in your own project. So that's it. Thanks for watching.